Lesson 27. 27? 27. We're going to look at a bunch of pictures today of data. Remember, a few lessons ago we talked about all the different types of graphs that you can have. Circle graphs, bar graphs, dot and line graphs, one variable, two variable, histograms, all that. Okay, well, they say that picture is worth 1,000 words, but what if you take data and you put it in a picture in order to get your particular point across, but what your picture says and what your words say are not quite the same thing. You can draw a picture to make something look like what you want to happen, right? We're all pretty good at misleading what the conclusion should be to a set of numbers. You want to look good, you can make yourself look good using numbers. Again, Josh Montai. But numbers don't lie, but liars use numbers. So I want to show you some stuff just pulled off the internet that is misleading. We'll tell you why some of these things are misleading, things you can look for, and then what would you do to fix it. If you're writing these things down, there's our different things that we're trying to do today. Analyze how graphs can be misleading. Identify what the thing is, and then say, how would you fix this? How would you tell a better story with a picture to represent your data? Okay, so let me talk about a couple things before we get started. In things like bar graphs and line graphs, typically, as you know, there'll be two axes with things there. One of the first things you want to do when you get to even like a standardized test, SAT or ACT or something like that, is to look what information that they're giving you on both of the axes. So you want to look at the labels. Okay, you want to see what is this graph about. Sometimes there's a title, and then they got the axes labeled with something. Say we had the other one that was like animals, and then we've got like frequency. Sometimes they have those things numbered, sometimes they don't, or labeled or whatnot. So you want to just look at the whole thing, take it all in for starters, and then start looking at what the graph is telling you. Are the bar graphs in order? Are they labeled in any type of alphabetical order or numerical order? How wide are the groupings or the intervals, especially on the X side of things? For instance, I have one sample one down here. I want you to notice a couple of things. One, you've got this zigzaggy thing right here. That's called a broken axis. And the broken axis just tells you we're not starting at 0. So that's one thing you want to look for, either on the x-axis or the y-axis. We're not starting at 0. Now I want you to look at the intervals there, like how far apart the dashed lines are, so that each bar represents a certain different amount. So you got from 71 to 77 is only 6 units. From 77 to 83 is 6 units. But 83 to 90 is 7 units. So really the bars are not equal width. That's misrepresenting the data. More things could be in the 83 to 90 because it's a bigger interval. There's more space there for numbers to go in. So to me, that's a misrepresentation. The scale changes as you go across. The scale needs to remain the same throughout the whole thing. So on that one, they had this. They had a broken thing. That is like giving you an indication that they've done something there, that the scale doesn't start at 0. And it's not so much a big deal on the x-axis as it is on the y-axis. If they give you a broken axis on the y-axis, that means they're going to start their numbering not really close to 0. So for instance, I put here that you got a broken axis, and then the first dash mark on your chart is a 50, then a 60, then a 70, then an 80. If I start drawing bars here to represent the thing, I do this. How much bigger does this one look than that one, right? It looks like it's twice as big. But really, the difference between the first one and the second one is only 10. First one would represent 50, the second one would represent 60, the third one would represent about 70, which is only 20 bigger than 50, but it looks like it's 3 times as big. That is a misrepresentation of the data because the scale over here on the frequency side doesn't start at 0. Now, if it did, this is what those graphs would look like. Now they don't look that much different, right? They're like, oh, they're all kind of big, it's just that one's bigger, but it's not like 3 times as big as that first one. So that's definitely something that you want to watch out for. Does the scale start at 0? Or is there a broken axis and it starts higher than that? They give you lots of other pictures in your book. More of those things where here's one in a guide that's got a broken axis here on the y, right there. It's got a broken axis, and you can see it goes from 0 broken axis to 20,000. Now on that one, they got this line chart dealie, and it looks like there's these big jumps and zigs and zags and stuff. But if you were to have that actually go all the way down to 0 and go up by 1,000 at a time, those differences wouldn't look quite so big, would they? Well, there doesn't seem to be a huge difference between 20 and 22,000 if we started all the way down at 0. But when we have 1,000 jump at a time and we start more or less at 20,000, it gives a not quite a right idea of where that graph would be on a bigger picture. So there's that kind of thing. Does it start at 0? Broken axis? Could be misleading. Does it make the differences look too big, or sometimes does it minimize the differences that are there? That could be another problem. And then definitely observing the categories or the labels on things. We have to imagine, for instance, there's a circle graph in your book on page 160. It says the circle graph shows the number of some types of sandwiches a deli sells in one day. So you go like Subway, and they're keeping track of how many sandwiches they sell. You have to assume, unless they tell you, these are all the different kinds of sandwiches that we have. If you don't see a menu, you have to assume that they're only telling you about some of the sandwiches. So in the picture, they've got tuna, turkey, ham, and roast beef. Would you like one of those, or would you like something else today? What would you like? Would you like a tuna sandwich? No. So maybe you want pastrami. I like a good thin sliced pastrami sandwich. It's not even on the list, right? So they're comparing only some of the data when a circle graph is supposed to compose 100% of the data. That's how circle graphs work. All the things are supposed to add up to 100, but that should include everything. In this case, that's on the menu. So first thing I would say is this: be observant. Look at all the details about that graph first. Look for broken axes. Look for equal size intervals. Is the scale too big or too small to be able to see differences? Either to see differences, or does it overemphasize differences? And then imagine, what would you be able to do to fix that? For instance, do you just need to draw bigger bars? Do you need to include all the information? What is it that you would fix about that in order to not be misleading anymore? It's a big problem in science papers these days. People have gone back over the last 10 years or so, and they looked at science papers and then double checked all their data. They found that in about 50% of all the scientific papers in scientific literature, about 50% of them contain some type of misleading representation of data, some errors in the calculations. But, if you want to make your point, lie. So you can't base your decisions and your conclusions off of stuff that's not accurate. So that's very, very important in science and math, physical sciences and whatnot. Accuracy matters. Honesty matters, and that's not super premium these days out there. So double check things, look for inaccuracies. You can only display what's true. Let the truth speak. There we go, a little bit shorter today for lesson 27, but I think you'll get the idea as you look at the various pictures and look at their explanations and then say, what would you do to fix that?